All right, the little red light
Recording
is
has started.
on. Thank you. All right, now we're going to sharing. Oh,
I'm just glad it's not just me.
sorry, guys. Okay, welcome to the meeting. Sorry, we lost 10 minutes on that. Welcome to today's virtual interim. As a reminder, the note well applies, and I'm sure that all of you have seen this before. So if you've not, please make yourself familiar with all of these points before you contribute. So today, for the meeting facilitation, the blue sheets, please go to the CodeEMD page and sign in to the blue sheet section. Minute taker, Rich, thank you for volunteering. Others, since you will be able to see what he's doing in the CodeEMD, please if he gets it slightly wrong, adjust it yourself. Jabberscribe, I'm not expecting that we'll be needing one today, and the slides are available at that URL. The goal of today is, since we're about to do a recharter to take on end-to-end email guidance, it seemed like a good time to ask whether there's other topics. Some people have already approached the chairs about post-quantum cryptographic algorithms and transition to them. So this virtual interim is about what, if anything, we want to put into that recharter to address that topic. So basically, the intent of today was to have a few quick presentations about where different people's positions are on that question, and then to have an open discussion and then wrap up. So any agenda bashes? Okay, hearing none, I will go to my presentation. Okay, I hope you could all see that. Somebody give me some feedback?
Yeah, I can see.
Okay. This is a presentation I gave last October at a NIST workshop, and my position hasn't changed, so I didn't update the slides. I think the goal in the deployment of post-quantum crypto algorithms is that we need to get that done before a large-scale quantum computer comes along that is able to break the algorithms that we use today. My assumption is that people will want to gain confidence in these new algorithms and the implementations of those algorithms in security protocols. We'll do that by mixing traditional with post-quantum during the transition. We have to recognize that upgrading PKIs will take a long time, and we have to recognize that upgrading security protocols will take a long time as well. So with all of those considerations, I have some thoughts to share. There's two approaches that people have been talking about. The two certificate approach has one public key and one signature, as we're accustomed to today, and you would basically use one with traditional algorithms and one with post-quantum algorithms during the transition. The other alternative, which we'll have some speakers talk about today, is to use one certificate that has a sequence of public keys in it, traditional and post-quantum, and has a sequence of signatures, traditional and post-quantum. In both cases, the idea is that in protocols where there is a session, you would use a key derivation function to get a shared secret from the traditional and a shared secret from the post-quantum, use a KDF to mix them together, and use that as the shared secret in the protocol. You could do the same thing in SMIME, or you could use double encapsulation for encryption and parallel signatures for authentication. When using parallel signatures, there's an attribute that was defined a long time ago by Sean Turner and Jim Schad that you put in both of the signatures that points to the other one so that an attacker cannot strip one or the other. So in the one certificate approach, security protocols do not need any new fields, but there's additional public keys in the certificate, and the security protocols still need to be updated for implementing the new algorithms. You need to modify the certificate architecture. The certificate architecture itself doesn't need to be updated, but the validation needs additional complexity to handle corner cases, like what do you do in a case where the signature of the post-quantum is good and the traditional is not, or vice versa. So these half-right cases need to be dealt with. And we also have some pitfalls from experience in the 90s with these jumbo certificates, which carried a key agreement key and a public key for a signature in one certificate for the same user. We had corner cases there that were problematic, and I just would like to avoid them. In addition, the certificates become quite large with these multiple cases. With two certificates, the security protocols do need a new field for carrying additional certificates, or at least a way to name which identity certificates if they already carry a bag. No need to modify the certificate architecture, and validation works exactly as it does today. It avoids the known pitfalls with jumbo, and I admit the two certificates are going to be slightly bigger than the one with the two fields in it because the subject, issuer, and other metadata are repeated in both of them. But one thing I think is really important is at the end of the transition, you just stop using the traditional certificate. Could whoever just join mute, please? We're getting an echo. And so the nice thing about the transition ending is you just stop using the one with the traditional algorithm in it. So my recommendation is that we use separate certificates for traditional and post-quantum, begin the security protocol work now for mixing the two, and plan for the day when we only have post-quantum in use. I will observe that when I was the security area director, we had this desire to shift from SHA-1 to SHA-256, and we had a big discussion about it, and we thought that would take 5 years. We were way wrong. It took closer to 10. So we have to realize we're faced with a transition of that magnitude. And that is the end of my slides. If somebody has clarification questions, I'll be glad to address them now. Otherwise, we'll move to the next position.
Can I make a few comments? I don't know if they're clarifications. For one is you highlighted how in the half-right case for composite certificates that it was difficult. Actually, if you want to actually preserve the property that that security relies on both, you really need to reject in all cases unless everything verifies. Because if you accept it, if one is good and one is bad, that means that the attacker only needs the one that is good. And another comment is in the two cert case, you said validation is easy. Actually, it becomes more complex because you need to modify each and every individual security protocol to actually use two certificates and to sign the appropriate data. I don't know if we really want to make some of the more obscure, to rely on the more obscure security protocols to getting that right.
I think I agree with most of what you said. I was just observing that in the certification path validation, that when you have the case where one signature validates and the other doesn't, you have to deal with that corner case. And you're saying it's not really hard to deal with. You just, if anything is out of whack, just say no.
That's correct. Otherwise, you're not meeting the security goals that we are trying to achieve.
Okay, any other comments, or are we ready for the next position?
Well, I was going to comment on the validation issue just a little bit as well. I think we need to be clear that there's the difference between the validation that goes into creating the certificate that's done on the CA side, and there's the validation that's done on the relying party side. On the first issue, I think we largely don't care because it is pretty much unchanged. But for the validation with two certificates on the relying party side, I am a little bit worried about the fact that, okay, you have two certificates that are binding subjects to public keys. But if with two certificates, you have the additional complexity of making sure that it's the same subject for both certificates. And that I think there's going to be a significant amount of fun in preventing people from doing some interesting mix and match attacks. So I don't know which way the preponderance of the evidence is going to go, but I see danger on both sides.
So I'd like to respond to that one just very briefly, which is I think we have the same problem with the certificate matching that we have today with when we have separate key management and digital signature algorithms. And we have several cases like in DoD where they have figured out how to make sure that all works. So I think it's the same already known how to deal with the problem.
I don't think, if I can respond to that, I don't think it's that these problems are unsolvable. I think it's, I mean, both ways there will be solutions. I think it's the question of trying to minimize the amount of foot guns, trying to minimize the
Sure.
tricky, like the number of places we're asking protocol designers to deal with tricky things. Minimization rather than an impossibility type question.
So Russ, I would have a question. So do we really talk about two key pairs and two algorithms to support in a certificate? So what I heard is from our crypto experts that we yet don't know which algorithms, and that we need to be agile to also transition from one PQ algorithm maybe to the next one. And therefore, is it really are we talking about two, a classical and a PQ algorithm, or do we have to be more agile?
I don't think that's actually a concern, Hendrik, because we have that same problem today in trying to decide whether we're going to do Diffie-Hellman or RSA or elliptic curve. On the traditional side, we have to be agile on both sides.
I think that is a good point, though, that some of these solutions admit two key pairs, where some of these solutions admit n key pairs. And there probably is a good discussion to be had about what is the desired behavior, whether n key pairs is actually worth the effort.
Okay, I actually know that Max is going to talk about that. So maybe the thing we should do is go to that.
Okay, perfect. Let's see. Let's see if I can provide you with some additional details. Russ, are you going to share?
I'm going to share. Hold on. Okay, I'm coming. Share content. Well, there we go. And now let me make it full screen. Okay.
Oh, it worked. Okay. Thank you, Russ. Today, as a position, I'm going to try to explain how our industry is planning to use it and what are the reasons why we think that this solution might provide a better deployment path for us for crypto agility purposes. And for this particular few minutes, right, I want you to abandon the assumption that you are living in a rapidly evolving environment. Okay, our focus is on devices that have very long expected life, 20 plus years, not 20 minus, is plus 20 years. And I think about when you think what I'm talking about, think about how many times you change your cable modems. So our task, okay, that we have to solve is transitioning hundreds of millions of these devices for the whole industry into a quantum safe state at some point and be able for them to operate on our networks. That means delivering the security for accessing the internet for hundreds of millions of people. And that's the reason why we really need to have a solution that is cost efficient, because otherwise, especially in secondary market, I envision the new algorithm to get there so late that we will actually have failed our users. So this is the purpose why we are bringing this here. Okay. So next slide. Just to give you a brief introduction, we don't use TLS in our networks. We use some parts in TLS, but the majority of our authentication uses a DOCSIS protocol. DOCSIS protocol has now two different authentication frameworks, PPI Plus version 1 and version 2. And we have a large deployed PKI, right? So I said it's been running for more than 20 years, hundreds of millions of certificates valid at each time because of this very large validity period, a few billions issued certificates overall. So these are the numbers that we're talking about, not your thousands of certificates, okay? This is a device certificates with long validity period. And so we have very specific requirement. So next slide. The other problem that we need to solve is firmware upgrades. So in our industry, because of the choice of the 20 years validity, we also decided that we needed a standardized mechanism to upgrade these devices. However, you can only upgrade the software, but the secure elements or the crypto elements might not be able to be upgraded to. And some of these devices might not have enough memory to actually be upgraded to use the new algorithm for even for validating other entities' certificate. So when it comes to the firmware, they will still be, we will still like to update these devices, and they still need to validate these firmware before they can trust it. So we need a solution. Next slide. So I try to set the problem here. We will live in a mixed environment, and the rest of the talk is about what are the problems that we're trying to address with composite crypto. So it's not about the security, it's about the deployment models that is needed for us to address this large number and all the ecosystem. And it's very particular, and I'm stressing the fact that I don't see this to be an alternative. You have to do this, right? No, this is a solution that can be deployed in your environment if you have the same problems that we are facing, okay? And this, I think, the reason we bring it here, because I think that these problems will be faced by many environments where you have devices and you want to extend the lifetime of these devices. You don't want to incur in billions of dollars to replace these devices every time you have a crypto failure. So we are trying to build a more resilient internet for everybody. Next slide. So at this point, we have two choices. We can do two things. Do nothing, right? From a PKI standpoint of view. Require, as Russ said, and as other people pointed out, that every single protocol that we use in our companies, not just the DOCSIS that we use to protect our users, but every single proprietary protocol that you might have deployed in your ecosystem, in your everywhere around the world. That's what we're talking about. Or we can leverage the X509 algorithm agility that was built in for this particular reason, right? And that means that we can be more effective and cost effective in deploying new algorithm. And that's the reason why we're trying to push this standardization, not just for us, but for everybody, okay? And especially because I think that the deployment of this cryptography will be more difficult in secondary market and growing economies. And we don't want to artificially inflate the costs just because we have to double all the costs. And that will be reflected in devices, will be reflected in services, and the possibility to access the internet. I don't like this. And I want to solve this in a different way. Okay? So, my point here is that solving the problem with the PKI for our environment is a way far better solution than try to address the problem from a protocol perspective. And this is what I'm going to try to convince you now in the next slides. And I try to convince you not because we think that we are going to go forward with this solution, because there's no other way we can have the same security properties in our environment. But we think that it could be very useful for other people. And that's why I push for giving up the IP and we come to the IETF. This is why we are here, okay? Next slide, not politics, next slide. So this is the situation that we envision in our networks in 15 years from now, not today, 15 years from now, okay? The majority of the devices will still be classic and valid capable devices, and I'm going to explain what that are. We are going to have, you know, a certain number of quantum safe devices, but I expect that to be inferior in number as the other two categories. So here we have 3 categories of devices: classic only, validation capable, and quantum safe. The classic only is devices that cannot be updated. You can try, they don't have enough memory, the secure element is only RSA, nothing you can do about it. The validation capable device, instead, they have more memory, you can upgrade the crypto library, they can validate the post-quantum algorithms, and maybe you can also add post-quantum camps, so you can start transferring securely also share keys, and we will look about why that is important. And then the last one is the quantum safe devices that we envision that we will not have to require them to have both secure element for the RSA algorithm and the post-quantum algorithm, whichever we selected. Or for the next generation, we would not like to have a situation where we have more of these requirements. The second problem that they say on the rows here, you can see the different operations that we still need to perform under the quantum threat in 15 years from now, okay? Signing with classic, signing with quantum safe, verifying with classic, and verifying with quantum safe. And if you pay attention to this table, you can see there's 2 main problems here, right? Next slide. The first one is that we need something that allows these devices that's going to be on our network, they're going to protect the internet traffic for everybody in our network, and they cannot perform their post-quantum authentications. This is the first problem that we need to solve. The second problem, next slide, is that these devices, the classic only devices, will not be able to understand these quantum safe new devices. And I can see this to be your cable modem that needs to authenticate the network. The network is quantum safe. Your classic device is classic. How do you do that in the 2 certificate environment without raising the costs a lot with all changes that needed to be deployed? Next slide. So this is just a summary of some of the considerations that we are starting to make, okay? Of course, the first one is, do you need to change the PKI? No, in the 2 certificates, no, because you just deploy a new one. So you're not addressing securing that infrastructure, you're just deploying a new one. And if you want to address securing that infrastructure, you have to do crazy things like signing, cross-signing, signing with a certificate from one infrastructure to the other, and creating the link that Tim was actually saying. That's a problem. Those are 2 separate certificates, can be 2 separate entities. What I want to authenticate is one entity and using the algorithm that I can understand. RSA if I'm a classic only, or post-quantum if I'm a post-quantum device. There's no reason for us to not have this option, because that's exactly what we need to do. We want to be able to authenticate the same entity with different algorithm, not authenticating two different entities. That's just not the same thing, okay? That's why it's important that we address this way, not the other way. Next slide. So here I want to provide an example of what are the type of problems that we are going to face. And many other people, we're going to face these problems. Maybe they're not thinking about that now because it's 15 years from now, and they don't have that lifetime expectancy. But in 10 years from now, they will find themselves in the same situation. So what they're going to do? So let's try, so next slide. So classic devices can perform their own authentications, and we can think about, and we develop an internal system to securely deploy these symmetric keys early, because right now we don't have any post-quantum mechanism, and we have some proprietary methods to do that. So when this authentication trace is sent to the post-quantum device, next slide, the quantum safe device can use the pre-shared keys to make sure that this is the source of this authentication trace is actually that device. So next slide. Not next one. Okay. Previous one. There should be another one. Anyway, so the next one. So if we have composite crypto now, you can think about that instead of having to protect everything and have to rely only on the classic crypto, our quantum safe device now can validate the certificate chain with the post-quantum algorithm, and the device can still sign with its own RSA. In this case, we will still have to combine the share key with the RSA signatures, and that's what we are actually planning to do. So next slide. If you think about the authentication on the opposite side, that's where you have the biggest problems. Next slide. You can think about having the same approach, having an outer shell that the classic device can understand. But after you remove that, there's nothing you can do. This classic device cannot understand if this chain should be trusted or not. Next slide. So what you do? In the two-certificate approach, you have to provide two separate authentication traces, and these devices will have to provide RSA signatures. We don't want that. It's not efficient. It's just not the right way to do it in our environment. Next slide. If we have the composite crypto standardized, then that will allow us the classic device to actually validate the chain. Not the last signature. That's the part that are still working. If we can combine the PSK in some ways, maybe. But the signature in this case, the security is provided by the PSK usage that protects the last link. In this case, it also protects the classic algorithm for chain validation, because the classic device unfortunately cannot use the post-quantum algorithms. So next slide. And the other thing that I want to draw your attention to is another big problem is indirect authentication. This is where the device cannot fetch the information directly, but has to rely on someone else on the network to fetch that authentication. And that fetching can happen before even I know if the device can understand post-quantum or not. That means I have to fetch both of them all the time. So I have to execute the protocol twice. Why? Just execute the same protocol and rely on the algorithm that you trust. And you can change exactly as Russ said. You can just not use the certificate when you don't trust that classic algorithm. You can just not validate the RSA if you can use the post-quantum. And for the devices that cannot, they can still validate other devices. So next slide. And a big problem is for firmware update, as I mentioned before. Also in this case, you can do it with two certificates, but we have to require all manufacturers to sign with multiple certificates, all our members to sign with multiple certificates, because this is something that has to happen even before you know which device this goes into, okay? So there might be, and you need to provide the security. So also in this case, For classic only devices, we will have to use something else. Next slide. But you can see how with composite crypto, you have better management of these objects, right? You don't have multiple signatures that indicates multiple entities signing that, but you have a single signature, that's the manufacturer that signs with multiple keys. And the co-signer, in our case, signs with multiple keys. But you can very easily understand who's the co-signer, who's the signer, instead of having who's the manufacturer, who's the co-signer. So there's a big difference in how you treat your protocol, your security, your roles in your protocol. Next slide. As I said before, for classic only devices, we will have to use something to protect against the quantum threat. And in this case, we can still think about the same approach that we used before. But think about this to be every time you need to authenticate something that is offline, OCSP responses, secure time delivery, document signing. This is what addressed the problem. And yes, you can do it with two certificates, yes, but then you incur in the problem of, is these two certificates represent the same entity, or are those two certificates different entities? Which one? And if I can trust only one of them because I understand only one of the two algorithms, does that cover the logic in my protocol? So this is the problem. Next slide. And last, this is something that I have a very particular vision on. Most of you probably don't agree with me, but there's added value in having both signatures in those certificates, is that you can differentiate between forged certificates and non-forged certificates, because at this point, to forge that root CA, you will need to factor or to guess also the post-quantum private key. That is today a protection that with the two certificate approach you cannot have. And I think that this concludes. I'm sorry, I'm very passionate about this because I've been very frustrated with the process. And I have to just say one personal note that I want to say, because ultimately what we are trying to deploy here is a solution to solve a real problem. And in the past, I've always had problems with working in PKIs because people are trying to block it for politics reason, not for technical reasons. And I'm strike this. And the fact that we had to have this meeting where I have to explain why and how we're going to use this protocol is just not okay. IETF should be about the technical merits, and how we want to use this protocol is our own business. Does this protocol provide a solution that solves a problem? Yes. Has good technical merit? Yes. So there's no reason for this group to block the work that we are doing that is important for hundreds of millions of people. And this is true for every aspect that we work in PKIs, and I want just to stress this. I'm sorry, I'm very frustrated because I really want this to move forward, and not just. There are some other issues that we will have to focus on. Revocation, OCSP needs to be reworked on because it's too inefficient. There's secure time delivery. We still have no solution for that, and that's a problem for devices that cannot access the network to fetch that information when they need to validate certificates. This is what I'm talking about. I hope that this gives us the opportunity to think about how we proceed in this work group and what are we trying to achieve. If you're trying to say we shouldn't do this work because there's a technical merit, I agree with you, and we will talk about and make it better. But if you just try to stop this for no technical reason, I will tell you, I will call you out, and I will make sure that your objections are really reported up, because that's not okay with me. We are talking about security and privacy for hundreds of millions of people. There's ethics that needs to be applied here. Okay, so I conclude my opinion. This is my personal position, it's not my company position, but I've been involved with the IETF for more than 20 years, and recently has been impossible to get any work done in this area. Things need to change. We are going to move forward with work, and I hope we can do it at IETF. Thank you.
Does anybody have any clarification questions or responses to the proposal from Max?
I have a quick question.
Go ahead.
You put up the slide that had the list of the pros and cons, the first slide that had the 1 versus 2. I didn't take notes, unfortunately. I know, is it hard? I guess my question was about the assertion of having multiple identities, where one is allowed and one is not. I don't know that that's necessarily true. Can you explain a little bit more what you mean about that?
I'm trying to look at the slide to see what you're referring to. But in general, think about this the way that probably whenever we see the slide. But in general, I think that the problem is that the link between these two different certificates, and that's the problem that you know, and that's the problem that we're trying to understand. Having a certificate with the same subject can be an indication of the same entity, but only that depends on the policy that is followed by the CA. So that depends, right? That depends. Can you have the same? Can you say that that's the same entity? That depends on the policy of the CA. So it depends on the environment. Does that answer your question?
So it is possible. Okay. So it's possible you could have, if you have the same policy, you could use existing identities across both. So it's possible. It's not binary. That's my point, right?
Let's put it this way: it's your choice. You know, if you say if these two certificates issued by the same entity, they have the same subject, I think they might be the same entity.
Okay. All right. And so the other bullet was there was no protocol changes for certificate selections. That is like the client being like, well, since I only have one cert to pick, I only pick this one, as opposed to if you have two. Is that what the point you're trying to get across?
But also on the server side, in the sense that in our protocol, for example, on the server side, the CMTS or your cable modem termination system actually uses a certificate, right? So it has to sign its own messages. So this,
Okay, I think I got it. Thanks.
Anyone else, or are we ready to go to Mike's presentation?
I'm really unclear what Max is actually proposing. Maybe if you could tell us if there's a draft or something. That I just heard the problem statement. I didn't hear the proposal clearly.
The proposal.
He did present internet draft at a previous face-to-face IETF meeting.
Okay.
And I think that was part of the frustration that he's having to justify why that solution is needed. Basically, I asked him to say, you know, what problem it was solving for him. But it's composite is was in the name. I don't remember off the top of my head, and I don't know whether it's expired. Max, has it?
Max is on mute.
Actually, it's under, I believe it's currently under Mike Unsworth's name, and it has expired.
Yes, no, we merged the two. If you remember correctly, Russ, we had two separate drafts. We merged the two, and we pushed forward the proposal combined, right?
Okay.
It actually expires on January 29th. I've got another week to add a comma to it.
January 29th would be tomorrow.
Yeah, that's right. I don't know the week. Another date, add a comma to it, right? Not currently expired.
I dropped a link in the chat room. You know, you can always just change the date and submit it. Just to keep alive.
All right. Will do.
Okay. So we're going to move to Mike's presentation.
Am I good to start talking?
Okay, Mike, go ahead.
So given that Max and I are the co-authors on the same draft, our presentations are going to have a very similar slant. I think I can probably, for this audience, blast through the first half of my slides. I do have a lot to say on this topic. I've been focused on this for several years. Hopefully I've condensed I think I have a lot of valid and different points to make. Hopefully I can get through this in a reasonable amount of time. Next. So first I have a specific LAMPS recharter suggestion, specific recharter text to propose. I'll just blast through that quickly here, and then I'll put it on the mailing list for people to read it in full. Then I'm going to make a pitch for composite signatures as a standard. And here note, like Russ and Max have been talking about composite certificates. I want to take a bit of a step back and argue in favor of a composite signature algorithm OI by itself. There's value in just doing that work. And then given that work, Entrust will go and stick it in certs, but we actually don't need a standard. Once there's a signature algorithm OI, we actually don't need any more standards. We can just go put it in certs and use it. But I will also make a pitch that is independently useful. That the composite certs is independently useful from composite signatures. Composite signatures is actually the thing we should be working on. So this is my talk. Next. Next. So I'm going to motivate here. I'll go, for this audience, I'll skip through this, but motivation for why hybrid and dual cryptography is a good idea. Basically, we're late in the NIST cycle and still coming up with new cryptographic attacks. The lattice stuff, the code-based stuff, the multivariate cryptography stuff, this is like really heavy math, right? RSA is sort of high school-ish, ECC is sort of undergrad math-ish. This stuff is heavy. There are not enough experts in the world to meaningfully do cryptanalysis, and so the timelines of cryptanalysis is much longer. Last week a bunch of new attack papers came out against the round 3 finalists, and NIST is weighing should we go back to round 2. Like that, this stuff is slow, and so we should expect attacks to continue coming out for years after the NIST standards are published. Next. So the proposal that everyone is talking about is these sorts of models. Well, if we don't know that we fully trust PQ, let's layer it with the existing stuff that we have. Sure, the existing stuff's not going to stand up to quantum computers, but it's been hardened over decades, right? We know it, we like it. Next. So I'm borrowing nomenclature here directly from NIST. I'm using the terms hybrid key establishment, and I'm using the terms dual signature. This is where it comes from, the NIST FAQ. Next. This speaks to Max's presentation. I think he's been over this a bit. This is our take on what the transition period looks like, also borrowing ideas from Professor Michele Mosca. And I want to point out that this hybrid period sort of applies in two different senses. We're talking sort of the first bullet at the bottom there was Max's point about 20-year lifetime devices. When can you turn off your RSA infrastructure? I think there's a second valid timeline to consider here, which is the timeline between the publication of a 0-day CVE and how quickly you need to scramble a patch for your, dilithium implementation. And if we go with assuming that these lattice algorithms are going to be broken and fixed multiple times, then I think it's in scope to consider mechanisms that reduce the severity of CVEs, that give us more breathing room on any particular bug fix patch. Next. So here's my LAMPS recharter text proposal. I'm not married to this text, but I want to throw something here. Basically, the last sentence is the good stuff. The LAMPS working group will update documents produced by the PKX and SMIME working groups to specify hybrid key establishment, encryption, and dual signature mechanisms. I think we should do it. I think we should take the call to add these hybrid mechanisms, and we should charter ourselves to go take a pass through all the stuff we own and make sure it's properly equipped to handle what I think is going to be demanded of these protocols over the next 20 years. If my presentation stopped here, I'd take comments, but I think I'll throw this on the mailing list for discussion. Next. On the list, there was a call a bunch of months ago for standardizing nomenclature. Here's my proposal to standardize the terms for discussion. I'm referring for this talk, and I propose that we refer to hybrid key establishment and dual signatures as the general concepts that match, Alice and Bob pictures with arrows. Composite is a specific instantiation of dual signature. It's the instantiation that takes multiple keys and multiple signatures and wraps them up into a single object, as opposed to a multi-key or multi-cert or multi-signature where you've got independently floating things. So Hybrid and dual are abstract concepts. Composite is a specific instantiation, and then draft Ounsworth there is the thing that Max and I are co-authors on, which is a concrete proposal for composite, including both the ASN1 structures and the generation and verification logic. Next. So, composite signatures. Here's my main pitch. I think that this working group should standardize a signature algorithm, OID, on-the-wire structures, and most importantly, the generation and verification logic for composite signatures. I think that's the most important thing incumbent on us to get right. Next. So this picture should be familiar from Russ and Max's talks. There's sort of, at a high level, two fundamental ways of accomplishing a dual signature. I do not see these as mutually exclusive. In fact, I see these as complementary. I could well imagine a world in which you want to get your backwards compatibility through a type 1 mechanism. And I'm imagining that your green key would be an RSA only key, that's your backwards compatibility, and then your red key is a composite key, that's your high security. So I don't see this. We've been trying to pitch this as an either or, which one's better. I don't think it's a which one's better. I think both are valid. I think both could even be valid together. So I really do think that a composite signature has value completely independently of this which one's better question. Next. So these sort of the stock arguments for composite protocol integration simplicity. It's just another public key, just another signature OID. As Max said, this is the crypto agility built into X509. Let's use it. The second half of this slide was covered by Russ already. I think you did a good job of summarizing the points. When you're carrying multiple keys and signatures, there's going to be gotchas, there's going to be edge cases that we're now forwarding on to every protocol designer is going to have to wrestle with the same problem. Why not do it once? Next. So having written this draft, which we wrote with Max at Cable Labs and Cisco and Icera and Entrust, and having spent a year of biweekly meetings getting this draft right, like it was a pain in the butt. There was a lot of edge cases to consider. And the generation of verification algorithms, we rolled back and forth all sorts of variations and came out with, you really got to keep it simple. You've really got to do all algorithms must validate. Having done that work, I do not want to force every protocol designer to have to go through those same arguments over and over again. Like, can we please standardize this once? I think there's value in just you want to do dual signatures. Here's a vetted way to do it. There's an OID for that. Next. And this sort of says the same thing. I have a bonus material at the end of this slide deck showing that CMS, the base CMS algorithm with multiple signer infos or structures with multiple signer infos doesn't accomplish dual signature because it doesn't prevent stripping attacks. Stripping attacks, that new thing you have to worry about with a post-quantum world that you didn't have to worry about before. I do acknowledge 5752, which adds the multi-signatures, and that's great as an extension mechanism, but sort of makes the point that getting this right isn't trivial. It's not free. Protocols are going to need extension mechanisms like they did in 5752 in order to get this right. Do we really want to force every protocol to add those extensions, or do we want to do it once in a central document?
Just for history, a point there, 5752 was about RSA with SHA-1 and RSA with SHA-256, two signatures you didn't want the weaker would strip. Right?
Which is exactly the same problem.
Exactly.
Yeah. I totally acknowledge that CMS has solved this with an extension, but it took an extension, is my point.
Yep.
And as Max so succinctly said, X509 has the algorithm agility built right in. Like, why don't we just use it? Okay. So now to certificates. Assuming that we charter to make this stuff in scope, assuming that we write a signature algorithm spec, well, then Entrust is just going to go ahead and use it in certs. We don't actually need a specific standard for putting it in certs if we do it as an algorithm. That said, I do want to make a couple points for why we think it fits, it belongs in certificates. The main one here is strong crypto. If you do a multiple certificate approach where you have an RSA only and a PQ only, and you use them to jointly sign a document, you're opening yourself up to manipulations where the attacker has both the RSA only and the PQ only to manipulate independently. You can imagine if they have fully compromised, say they know about a 0 day in the PQ, they can fully remove any reference to RSA from the certificate and then re-sign it with their compromised signing attack. Whereas if the CA chain is composite all the way to the root, you've got much stronger protection to detect that, hey, there should be a second signature on this document. So we think that putting it in certs all the way to the root is actually necessary to get the security properties you're looking for here. I'll also point out failure modes in end users. And I know standards bodies don't love thinking about end user frustration, but I will point it out that now we're going to be asking users to juggle 2 CSRs and 2 certificates. This sounds like a usability nightmare. And the last point there is, yeah, protocol complexity. That's been mentioned already. Next. So and then management complexity, and this is to Max just did a whole presentation on this. Doubling the number of certs means double the amount of headache to administer in large PKIs. Think about Joe admin who just wants to load up some SMIME certs for their end users. They don't know or care how this stuff works. Now they're gonna have to juggle 2 CSRs and make sure the right private keys get matched with the right CSR. And as much as I'd be happy to sell twice as many certificates, I just don't want to go there. It just sounds like a customer support disaster. Whereas binding, a single cert that just does the strong crypto just sounds cleaner from a customer support perspective. Next. And I have here a couple. These are sort of the standard arguments that I've seen. Having signature primitives that combine arbitrary pairs increases risk, increases complexity, increases footguns. Yeah, cool, good argument. I do see that point, and that comes back to whether we need to support explicit pairs or whether we think we're going to need entities to have 3 or more key pairs. We want to hedge our bets that any particular lattice scheme might get broken. Maybe you want RSA in 2 different lattice schemes, and now maybe we should be considering things that are fully flexible to allow arbitrary numbers of keys and signatures. If we want to go pairwise, we are working on an update to the draft that takes explicit pairs. And if in the bonus material, I've got the ASN1 structures for that. So you could define a signature album, composite, RSA, and dilithium, and then you've explicitly locked in the pair. And we're trying to define the ASN1 information classes so that just compiles cleanly using our on the wire structures. So you don't need to worry about that. You can just go ahead and define a pair and it falls out of our draft. The other argument is the jumbo certs. First off, I read through that thread, Russ. Almost all the criticism of jumbos that I saw related to the mixed key usages, that your signing key should have non-repudiation properties, but your encryption key should be escrowed. And how do you handle those conflicting requirements in the same cert? Those were the kinds of debates I saw. I didn't see a whole lot in that thread that jumped out as being applicable to composite, with the exception of size. And I do want to address the size argument. We're about to have a presentation. The next presentation, I think, is on hash-based signatures. Those are big, right? Those are like 20 kilobytes for a signature for hash-based. Lattices, you're looking at five-ish kilobytes for a public key and a signature, and then 1 more kilobyte for the RSA. So I would actually argue size works in favor of composite, not against it, because it allows you to use 2 smaller algorithms for a combined size of 6 kilobytes to get the similar security properties as a hash-based signature at 20 kilobytes. So I think comparing composite to PQ only or RSA only is a red herring. Yeah, of course they're bigger. You're taking 2 things and combining them for stronger security properties. But you get you get 1 step up of security properties for not a step up of size, using hash-based as my comparison. So I don't see the size argument. And I think if anything, it works in favor of composite, using 2 smaller algorithms instead of 1 big one. And I think that's the end of my slides. less the bonus material at the end. Next slide, I think is a summary. Yeah. All right, that was a whirlwind. I'm done.
Okay.
Questions for Mike?
One minor correction. In terms of hash-based signatures, if you look at the smallest Sphinx Plus signature, that has a signature size of roughly 7,800 bytes plus maybe what maybe brings up so a signature plus a public key would be around 8K, not 20K. Of course, you get a long, a rather expensive signature operation, but such is life.
Fair. And you also have to trade in, I mean, how many lifetime signatures of that key, and you know, when you get into max's size of PKI.
Oh no, I'm sorry. This is Sphinx Plus. The maximum number of signatures is like 2 to 64.
So there's lots of trade-offs in the hash-based stuff about how big a tree you use and so on.
Okay, so if you don't,
again, this is Sphinx Plus. It's already been basically it scales up to essentially infinite, as many signatures as you could possibly want.
So if you don't want the hash-based argument, the other argument for size is if you're going to take a 5K dilithium or Falcon object, then adding another 1K of RSA is not.
Yeah, no, I totally agree. I get that.
Yeah, it's. I think no matter how you slice it, there's a one more bucket to the dump truck argument here.
I'm just correcting your figures, not your conclusions.
Anything else? Or are we ready for Antonio?
Yeah, it's John Gray. I was just going to add. So I'm from Mtrust as well. So as an implementer of the spec, or looking at implementing and doing basically prototypes with it, it definitely, like the protocol backwards compatibility has been. It's a great feature of the spec, because, for instance, 5280, I'm able to do CSRs. I'm able to create certificates and do everything. I don't have to change any of my logic in my code for how 5280 validation works. It just works when you consider it as a signature algorithm, because it's just another signature algorithm. So you implement the signature primitive, which just happens to consist of 2 keys, or post quantum and a classical, and it just works everywhere. It's quite nice having that property. So I just wanted to point that out, and with having some experience with that and actually implementing that. So.
Okay, Antonio, are you here?
Yep. Hi everybody. So I'm new. This is the first time I present something at IETF. Thank you for adding me last minute, by the way. Can you hear me?
Yep, hear you fine.
Okay, perfect. So, yeah. Okay, so I'm a colleague of Hendrik, who I believe you know quite good already. I'm also working at Siemens, so probably I have a take on the problem, which is, let's say, a completely different angle. Oh, no, not completely, slightly different. Next slide, please. So, how to say, we probably in our industry, or in our we don't have such a clear view as most of you guys have. We have to deal with many products which have, I would say, rather different use cases and rather different life cycles. So sometimes it's a little bit difficult to see the light, how to say. And we are here, so I'm here today mostly to share a little bit of experience with it so far, try to gather ideas and gather opinions, of course, and suggestions. Of course, many of the products in our industry also have a very long lifetime. We also have products which go to 20 plus years, but also have different products with different life cycles. So maybe they cannot be bundled all together. And of course, I believe for us, protection of firmware and the overall protection of how to say, have a secure update mechanism in place is in focus, because we believe that that basically would be the, how to say, the building block that we need to develop or deploy successful post-quantum migration strategy. And this is where we are looking at right now. And yeah, I would say the topic with which we are trying to make some experience. And next slide, please. So we have started looking at stateful hash-based signature schemes. We think they, how to say, they could be quite useful in supporting our use case of protecting firmware. So typically with industrial products, you don't many signatures during the lifetime. But you are of course interested to have those signatures secure. And if we have to look at something that is already quite secure today, as a matter of fact, already standardized by the NIST, we decided to. So we have hash-based signatures, stateful hash-based signatures, and the size of the private key generation time doesn't seem to be a big issue, especially if we think to generate these keys and how to say, use them in a centrally controlled infrastructure. And the size of the signature appears to be quite small, so it's quite small, so could be a good fit for embedded devices. When it comes, of course, also to other algorithms like stateless hash-based, so Sphinx Plus, and all the other NIST finalists, I think we probably don't have a clear opinion yet whether they could be useful or not, but clearly they can be relevant for similar use cases, so similar to firmware signing. And yeah, as I was already saying in the beginning, we think so the target, especially for this type of use case, should be to use a common security infrastructure which is centrally managed to, of course, to host the key pair and to perform signatures. And the benefit would, of course, be that we can easily enforce some tighter controls. And especially when we speak about stateful, this seems to be rather crucial because we need to have quite, how to say, strong technical ways to keep an eye on the state, so to make sure that the state is not altered. Next slide, please. So yeah, what we had today, we how to say, we did not start that long ago, but we already did quite some experience. I to say with this type of use case, we started also getting in touch with some vendors, and you can imagine also HSM vendors, of course. And we noticed that there is quite some job to do there. So it looks like that there is no cross-vendor integration. So there is no, how to say, common common standard or common simply definition of the algorithms, or even the input or the output for what matters. So it is at the moment it's quite difficult even to make experience with the tooling that is provided by the vendors. Nevertheless, we started trying out something with XMSS. We simply started from XMSS. We don't have really how to say preferences for it, any preference for it. And yeah, as I was saying, we tried to basically see how it would play out in an environment where you would have a central security infrastructure that you use to perform signatures. But yeah, we see that there is, as I was mentioning before, this cross-vendor compatibility is simply not there. But even in the XMSS itself, in the algorithm, it seems that there are some shortcomings that still need to be addressed. As a matter of fact, a colleague of mine opened an errata to address some of these problems. But yeah, I believe this is normal life of the algorithms and RFCs. So I guess we will anyway get that sorted out over time. And then the other point that we noticed, and I already got an answer from us. Thank you for that. We see that as of today there is only an RFC to use LMS in CMS and none for XMSS. We understand that the reason is that simply nobody until now, of course, volunteered to put some effort into that. But we think even if when we speak about firmware signing, maybe CMS might not be the only way. Maybe there is a lot of proprietary stuff for plain signature or whatnot. But we think that, of course, putting some effort in this kind of activities and in this standardization can anyway help finding out issues about the algorithms and eventually help also with these integration issues that we face otherwise. And next slide, please. So yeah, then this basically just leads to my last slide, very short presentation. Some open questions for basically this roundtable, which we would like to discuss, hopefully get input and feedbacks. And the first thing, would it make sense to put some effort in drafting an RFC for the usage of XMSS in CMS, or even other formats that could be relevant to, why not even other algorithms? Then second bullet point, I already got the answer from Russ. Again, thank you. We were not sure why there was only, as of today, an RFC to standardize the usage of LMS in CMS, but that's quite clear, but of course we can discuss about it. And then, yeah, as I was mentioning also, if we should already start looking at other algorithms, so all the NIST finalists and Sphinx, would it make sense to start doing any work in that direction already? And then something maybe how to say, to close the loop and to get to talk again about certificates. We see that there could be some interest also in how to say, mixing these hash-based stateful algorithms with long-lived certificates. So I guess we don't have a clear opinion on whether it should be a composite or any other format. But yeah, there could be definitely some value there because we might need to deploy today trust anchors that need to be valid, of course, for a very long period of time. So yeah, if it would be interesting for this working group to look into this approach as well. And that would be it from my side. So thank you for the attention. If you have any questions.
So Antonio, the XMSS is already within scope, within the charter. So if somebody is interested in doing that work, just submit a draft and the group can look at it. I think in terms of the Sphinx Plus, we're waiting for NIST to decide whether that's going to be a standard or not. And in the last point is what the last three presentations have been about. So we'll see how that turns out, right?
Right.
Any other comments from someone else?
Can I speak, Russ?
Okay.
Can I
one
speak?
matter, I had a correction. You said that basically hash-based signatures are among the smallest. They tend basically to be maybe 1 to 3K depending on the parameter set. I believe that multivariate signatures tend to be much smaller.
But keys are much bigger.
1.2, 1.3 megabytes, and signatures few hundred bytes, usually like 200-300 bytes. So I saw those.
That's multi. Okay.
Yeah. Regarding to the Sphinx Plus, right now, our opinion is that likely we will standardize Sphinx Plus, some of its version after the round 3. That is current thinking. I cannot make promise for this, but that is our current thinking. And I think likely that is going to happen. But what specific versions of Sphinx Plus, we have not decided yet. Yeah, and if for the other signature algorithms, we will try to make some sort of conclusion or some sort of official opinion about them at the end of round 3.
Understood. Thank you.
No problem.
Okay, we have one more presentation. I don't think we've met in person, but
Hi. Yeah.
okay, can everybody see the screen?
Yep.
Okay, go ahead.
Thanks, Russ. I'm Tadahiko Ito from SECOM. We are running certificate authority and also some key management service. Next, please. Yeah. Well, I make like today's overview in this single slide, and my presentation is all about how to support diverse size of data. And current PQC seems okay with authentication and small data. Well, current PQC seems okay with signing for large data, but only with pref hash. And for like, however, it seems we need to differentiate two use case or to use same protocol for two use case. And it seems we have an issue. So I'm trying to share this issue and like want to ask what we should do. Next, please. So use case for signing, I'd like to point the use case of signing purpose, because for example, like we use HSM for signing purpose as a key management service authority. And for example, for some medical data, they have some like multi-slice CT data and which have a 2 GB for single inspection. And we do kind of document signing for those data with certificate. And also we have some CAD data for something like building or whatever. And we have a PDF file for building CAD data. And that can be up to something like 10 GB. And we sign those data with document sign technology. And not that like those, like, for example, those multi-slicing medical data's lifetime of the data can be similar to lifetime of the human. And those CAD data can be like the lifetime of those CAD data can be lifetime of the building, which I'm not quite sure how long it should be, but anyway, so for those things, like we have a huge data size and long lifetime of the data, and I feel like I need to prepare, our company need to prepare for PQC like algorithm for those use cases. And next, please. And we implement some PQC signature algorithm on the HSM, and it was slow. It is partly because it was software implementation, and we don't have a hardware accelerator, but like it was slow, even with 10 mega file. We need to, in our use case, we need to sign for 10 gigabyte file or something, so, and it is problem. Next slide, please. Yeah, so in the current practice, we have a data controller server, data controller service only calculate hash, and that data control server send fixed size of hash value to the key management service. And key management service only signs the data, like something like RSA 2048 signature. And like, oh, sorry, this is not, like right hand is not ECDSA 256, it's hash SHA-256. Anyway, so in that like architecture, we are happy that like, because key management service don't need to watch some data, and sometimes they have like it is fine. But one, because of the HSM doesn't need to handle large data, and two, because HSM doesn't need to handle like potentially privacy data, and it is good. But it seems we cannot do that approach with some of current post-quantum cryptography things. Next slide, please. Because like it seems we cannot separate hash and asymmetric operation for some PQC algorithm, because like we need some secret information as the input of the hash algorithm. And well, yeah, next slide, please. So to solve this problem, we may be able to introduce one more like external prehash outside the HSM, and inside the HSM, like we may able to use NIST PQC algorithm or something like that, and make some public key cryptographic like protocol. It might be like one approach, but there is a problem with that approach. Next slide, please. So, like as I think it was Panos, like Kim, who pointed, but if like we use without prehash approach for small data, and with prehash with large data, the first problem is like I'm not quite sure we can have a clear line between those like upper use case and lower use case. We might be differentiate by like key usage or something, but like as a S-MIME, as we may not like differentiate authentication purpose and signing purpose. I'm not quite sure if we can have a clear line, we can draw a clear line for both of them. And also, we may need to differentiate this like two asymmetric operation or hash part, because some adversary can use prehash one to attack like without prehash one, as like Queen pointed. Next slide, please. So I'm thinking that like, well, I'm not quite sure if it is like IETF's like work for or needs to work or whatever, but we may make compiler for PQC signature protocol and hash algorithm, like take input or like PQC algorithm and hash signature algorithms as the input, and compile both of them and output general PQC protocol compiler, so that like PQC algorithm can be any PQC algorithm, and prehash algorithm can be any prehash algorithm, and possibly to generate general PQC signature algorithm. And that designing those compiler might be like done parallel to NIST PQC project, but I'm not sure where to discuss that topic yet. Anyway, yeah. Next slide, please. Okay, that was my position talk, but like some of you may interested in PDF signing structure. So I'm going to explain about that. So on the PDF document, the structure is left-hand side. So they have a PDF header, and then they have some green area. It's called signature dictionary. It's called a single signature dictionary file. It's like green side, and between green, we have a PKCS7 or CADES signature or timestamp data. And they have an end of the 5 things. And so that is PDF like document. And that pink signature is signed for those blue part. So blue part. So TB signed area is kind of separated up and down. And we concatenate those two and sign and put into that pink area. And right-hand side is sequential, like PDF serial signature. So when we update PDF, that's PDF signature to version 2, we the TBS part for signature 2 became a version 1 part and like separated version 2 part. And sign those like TBS part to sign those separated TBS part and put that second signature into signature 2 area. Yeah. And so on to signature version 3 or 4. And we put those signature in sequentially. Next slide, please. Like we have a restriction for PDF signing, single signature dictionary, like that green part with single CMS signed data with pink part with single signer info. So if we want to support like one signature, like hybrid, one signature story, one certificate story for PQC and like composite signature. It's very tough, but we had to it shouldn't be that much problem for separate signature story, since we had already deal with SHA-1 and SHA-2 migration, and it should work with like SHA-2 to PQC story also. So next slide, please. So it can be used for something like RSA signature 1, then RSA signature 2, and PQC signature like sequential version serial version up. And yeah. Anyway, yeah. That is end of my slide. Yeah.
Okay, thank you. Any comments on that presentation? And thank you very much for.
Okay. Start off with, I thought that you were suggesting basically having a standard way to having an optional pre-hash. At least for dilithium, I don't know if that is strictly required. Dilithium works in particular by hashing the message and then appending some data to complete the hash. And just then using that hash. What you could do is having your off HSM processor compute the hash and give the HSM the hash state, and there your HSM is able to compute everything without hashing the full message. Would that be a viable alternative, which would be completely compatible with standard dilithium implementations?
So, oh wait. I might be I might be not able to get your comment, but so with HSM, like if HSM and data controller can like interactively communicate or something, like it can calculate like yeah, it might be possible to solve the situation, but in that case, like implementation of HSM became much more complex, and for that, like I think we need consensus of that, and also like if like data controller only needs some public, like sort or something, like, which is not necessarily to be secret. It might be okay, but like for that, we had better to have a consensus of that, like data flow. So I'm thinking like we may need to have some consensus. What like should we do for those data, like large data sets?
Yeah, all I'm pointing out is there appears to be an alternative way to solve this problem if they is deemed to be complex enough that Pascal-Hassan's alternative solution is worth the has better. That's the working group problem. Well,
Yeah.
I think that Scott is just proposing an alternate API for passing the hash state so that the HSM can pick up where the outside left off.
yes, that's precise. At least in terms of dilithium.
It might be so like one solution. Yeah, but yeah, but well, don't we need like even for that like alternative API, we had better have a consensus about interface of API so that interoperability problem doesn't happen. No.
That API question is be more against with the user of the HSM and the HSM itself. It's nothing. LAMPS need not concern itself with it.
Okay.
I also think this would be a discussion, since it would have to do with algorithm specifics that might belong at the CFRG as opposed to LAMPS.
Okay, yeah.
Okay, are there any other questions about this presentation? If not, we'll move on to the general discussion about chartering. I hear several people who would like to see us move forward with standardization of the composite signature approach. Are there any people who want to speak against that? Okay, I want to highlight while people are thinking that please go to the blue sheets and make sure you signed in. We only have 20 people there. We have more than 20 people in the WebEx. Please help us capture who was here. Okay, hearing no one speak against composite, I think we will put that in the draft charter. Mike, you proposed some text. Would you please send it to the list?
Already done, sir.
Thank you. I'm not watching my mail client right now. Pushing slides forward and such. Okay. So that was a signature approach. Is there anything we want to do about composite key management? Max, I think you had some things in your slides about that.
Not at this time. I would say that for now, the signature is the most important pressing need for us.
And I would.
And when you say key management, I just wanted to ask, what do you mean?
A shared secret that is produced by the by a traditional and a post-quantum key agreement scheme.
Right. That is something that we have our solution, but we are open to look into a standardized one. Let's put it this way.
The charter text I proposed, I included all three: key establishment, encryption, and signatures in hybrid and dual modes. I personally don't feel comfortable speaking to key exchange and encryption, is why my talk and my work is focusing on signatures. But I do think it's work that this working group needs to look at.
So maybe I should back up to your proposed text. See if I could find it. There we go. See if I can. So this is the text you sent?
Yeah, I think I made one typo change before I sent
Okay.
it. I changed hybrid key establishment to hybrid key. Hybrid key. It's NIST wording. NIST wording is. No, that's right. I'm sorry. Yeah, there's a hybrid key exchange further up that needed to be an establishment. But yes, that's the text.
Okay. So is this capture the work that people want to do?
So I have no disagreement with this text or with this proposal. The question I wanted to ask is, does this work require or would it benefit from revising 5280, which I'm increasingly think has gotten long in the tooth in a lot of places, or pushing it to internet standard or something like that? I think that actually fits an existing charter in some ways, but
yes, 5280 already is a full standard.
it is already a full standard, so we don't need to go to internet standard, right? Okay.
Right.
So the text say just update. Can we allow to write new documents if needed, or we just need to update things? Because the sentence seems to say that we only update existing documents. But I wonder if we open ourselves to write new documents if needed.
Usually we write a new document which says it updates some other document. So I think yeah, answer is yes.
I think I agree that the charter text would be usefully improved if it were more clear to make that explicit, though.
Okay, but we could do that on the mail list without using valuable FaceTime to make that point, I think, as long as this is the scope that people are interested in. I think we've come a really long way in the time we've put into this today. If this actually captures the work people want to do. Hybrid key exchange and dual signatures is the point of this text, I believe. And then what protocols it applies to.
And speaking more to the intent here, there may or may not be changes needed. I think the work is to do a comb through what we have and decide if suitable mechanisms already exist or not.
I see. And where appropriate, make updates. Okay.
Okay, that sounds good.
Or where needed.
And in here, we have roughly the term hybrid key exchange and dual signatures. But how we will finally make the formal definition for these terms, right? Later, right? It's just a concept, right?
I think that earlier in Mike's presentation, he defined them here.
Okay, and
no, go forward a few slides for the definitions.
Go forward.
Okay. So that's
the back.
so we're talking about those definitions. Okay, we talk about those definitions. That's fine. Yeah, because without that, I didn't know where those definitions we do.
And these definitions are quoted directly from NIST's PQC FAQ.
Yeah, I understand, but I just want to be sure about that because I think these terms, NIST, there are other people have used different terms before NIST use these terms, so I'm not sure which we're referring to. But right now, look at this. That's what we meant, and I'm fine with.
We can certainly define these terms in the charter as well.
I have one question. Does it cover the separate certificate, use of separate certificate?
I think the current charter would allow us to do the work to assign OIDs for whatever comes out of the PQC process as individual certificates or so on, if that was needed, although I'm expecting that NIST would assign those OIDs.
Sure. Thank you.
Actually, I thought I saw some work by ANSI where they are starting to look at that process, so we may want to talk to them as well.
Is that in X9 or where else?
Yes, I remember. I think it was X9, yes. I'll go back and look it up.
And X9 is extremely unlikely to get into the OID assignment business. They're doing some hybrid stuff in F1, but I doubt that will have OIDs. It's probably more. It's intended to be more along the lines of transition to hybrid algorithms. So we should keep a close eye on that work, but I don't think it will impact our stuff too much.
Okay, so this came to consensus much faster than I expected. But it looks like that there's interest in doing this work. And we have a charter discussion now started on the lift. Let's bring that to closure. We will add the text to do the guidelines that DKG brought to us. And then pass it to our area director for chartering. So if there's no additional business, we're going to end like 9 minutes early. All right. I think we're done then. Thank you.
Thank you, everyone.
Thank you.
See everyone in person in a year. See you all in person in a year.
Okay, bye-bye.